Hello, what are limits? And why do we use limits? Are they really that important? And how do we find limits for different functions? Well, all of this is going to be in today's lesson. But first, Assalamu alaikum. Welcome to my channel, Fi and Maths, providing physics and mathematics tutorials for secondary level and beyond. Make sure to subscribe to easily find all videos and to write down on any requests you may have in the comment section so they may be added in future lessons. Now let's go back to our topic. What are limits? Well, let's zoom in. If I have a simple function that is f of x is 2x plus 3. If I look for the value of this function at x equals 2, then I will get the value of 7. 2 multiplied by 2 equals 4, 4 plus 3 equals 7. But what if I want it at a value that is so close to 2, but not 2 itself? What if I want to find it at the closest value possible to 2? Like, what is the closest value possible to 2? Well, the closest one I can think of right now is 2 or 1.9. Well, actually 1.99 is closer to 2 than 1.9. Well then, 1.999 is closer than both of them. And 1,999 is the closest of all of these. Well, I can continue like this forever. As long as I keep adding nines, I'm just going to get a value that is closer to 2, but not actually 2, because there is actually an infinite number between just 1 and 2. There is an infinite number of numbers of values between 1 and 2. So how can I get the closest value to 2, or what is the value in y for the closest value to 2? Okay, let us find the value in y for those ones. Well, if x equals 1.9, then y equals 6.8. If x equals 1.99, then y equals 6.98. And 1.999 gives me 998. And 1.9999 will give me 3 nines and then an 8. And I can see that there is a pattern here. There is a pattern here. Well, as I get close to 2, I'm getting close here to another number. Well, 6.8 is very close to 7. But 6.98 is closer to 7. Well, 6.998 is closer to 7 is closer than those two values. And the closest of all of those values to 7 is 6.9989. So as I get close to 2 on x, I get close to y. I get close to 7 in y. So I can say that the closest value to 2 will give me the closest value to 7. Like, what if I say that, okay, 2 equals 2.1? It's also very close to 2. Well, what about 2.01? Okay, what about 2.001? 2.0001. I'm getting closer to 2 also, but on the other side. Well, here the value is 7.2. And then 7.02. And then again 7.02. 0.002 and then 7.0002. So in both cases here, as I get closer to 2 on x, I get closer to 7 in y, but just on different directions. Here I'm approaching 2 from 1 and going up, while here I'm approaching 2 from 3 and going down. And instead of doing all of this excruciating work and redoing the function many times, I can simply say, as x approaches 2, y approaches 7. This is a simpler way to just say that. To say all of this, I just say, Wallahi akhi, when x approaches 2, y approaches 7. And this is the basic concept of limits. When we use limits, we actually mean that what we're trying to do is to find the value for y when x approaches a certain value. And we write it, the limit of f of x when x approaches 2 equals 7. Now, of course, 1.9 does not equal 7. It equals 6.8. And 2.001 does not equal 7. It equals 7.002. So that's why we say it approaches. We do not say it equals. It approaches. It comes really close. And so this is the meaning of this. The meaning here, as x approaches 2, y approaches 7. The approach can come from two directions. It can come from the right hand direction, and it can come from the left hand side direction. If we have a line like this, and let's say we have 0 here, 1, 2, and 3, we notice that here I'm approaching from the left hand side, while here I'm approaching from the right hand side. And so the limits for the left hand side and the right hand side are different, because here it's the same. In this specific function, both of them will approach 7. Like in different functions, they may have different approaches. And so we can say that the limit of f of x when x approaches 2 from the right hand direction equals 7 here. When I put this small cross next to 2, I mean by right hand side. If I do it like this, limit of f of x when x approaches 2 and then put a small negative equals 7. Here I'm approaching from the left hand side. Most of the time we will not need to be looking at right hand and left hand side, but there are some functions where we actually have to look at left hand side and right hand side. We can have an example of a function like this. If f of x equals x squared when x is greater than or equals 3. but it equals x plus 1 when x is greater than, or sorry, when x is smaller than 3. Or let's reverse it. When x, let's make it here, when x is smaller than 3, it equals x squared. And it equals x plus 1 when x is greater than 3. Now, here I have added a condition to my function. That means the value of x is going to define which one of those I'm going to use. If x is smaller than or equals 3, then I'm going to use this, x squared. But if x is greater than 3, then I'm just going to use x plus 1. So if I represent this function, and put here 1, 2, 3, and 4. Let's put 2, 4, 6, 8, and 10. So when x equals 0, it's smaller than 3, so x squared, 0 squared is just 0. When x equals 1, 1 squared is 1. When x equals 2, 2 squared is 4. When x equals 3, 3 squared is 9. لحد x is smaller than or equals 3. So until 3 we are okay. And it goes the same with the negative side, because negative 1, negative 2, and negative 3 have the same values. Then we can have our beautiful curve. But this curve has to end exactly here. Now, when x is greater than 3, I have to use a different method now. Let us make it, let us change it a bit and say that when x is actually smaller than 3. So when x is greater than or equals 3, so starting from 3, I have to use this now. So I cannot use 3 with x squared, so I just have to erase it a bit. Until 2.9, it's okay. But 3, I have to use now x plus 1. So when x equals 3, x plus 1 is 4. When x equals 4, x plus 1 is 5. And when x equals 5, it's 6, and so on. So the function is going to be like this. This is the whole function with the two conditions for the function. Now in this case, if I am going to look at the limit when of f of x, now when x approaches specifically this number 3, 2, 1, negative, 4, even all of those, we have no problem with them. But when we are looking at 3, if I am approaching 3 from the right hand side, that means I'm approaching 3 from this way, then I'm going to have a value that is here. It's going to equal something about 4. About 4. But the limit for the same function when x approaches 3 from the left hand side is here from this side. You will find out that it's going to equal something that is close to 9, very close to 9. Because here you're going to say that because it approaches 3 from the positive, from the right hand side, it's greater than It's greater than 3 because 3.1 is greater than 3. 3.01 is greater than 3. 3.001 is greater than 3. So we have to say x plus 1. And so 3 plus 1 is 4. 3.01 plus 4 is 4.01. But when x is approaching 3 from the left hand side, it's 2.9, 2.99, and so on. All of those are actually smaller than 3. So we have to use x squared. And when we use x squared, we're going to get a value that approaches 9. Bear in mind that this left-hand side and right-hand side only applies to this value. Only applies to 3. It does not apply for the other values. All other values, the left-hand side is going to be the same as the right-hand side, simply because the function is continuous at those values. But here, the function, you can see that the condition for the function changes at 3. So at 3, the left-hand side and the right-hand side of limits are going to be different from each other. So in general, this is limits. This is all the concept of limits, and that's all about limits. Then why do we use limits? Why do I have to actually use a limit? Well, if I have a function, let us write first y limits. If I have a function that is f of x equals, let us say x minus 2 divided by x squared minus 4 or minus 9. Now this function, the domain for this function is all real numbers minus 3, because if I use 3 in this function, I'm going to get 0 in the denominator. So I cannot find the value of this function at 3. There is no way that I can find the value of this function at 3. But I can use limits to find the value of this function when x comes really close to 3, either from the left-hand side or from the right-hand side. So I can use limits to find values for functions when they reach, when x reaches a value, or when x approaches a value that is out of the domain of my function. That is out of the domain of my function. So I can say that the limit of f of x when x approaches 3 here equals, we do a whole operation when I say 3 minus 2 divided by 3 squared, which is 9, minus 9, which equals 1 over 0. And then this does not work, so I have to do something different. But in the end, I'm going to find the value. Or let's just do it. First of all, let's just change this into x minus 3. If I expand this expression here, I'm going to have x minus 3 divided by x minus 3 and x plus 3. And x minus 3 goes with x minus 3. And so it's going to be equaling 1 over x plus 3. So the limit of 1 over x plus 3 when x approaches 3 is going to be 1 over 6. So I cannot find the function at 3, but as it approaches 3, I know that the function will approach 1 over 6. So when x approaches 3, I know that this function is going to approach 1 over 6. And practically, if I have a car that has to go from point A to point B, and the distance between point A and point B is 80 kilometers, and the time it took to reach there is 1 hour. Then you can say that the average speed or the average velocity for this car is 80 kilometers per hour. Why do I say an average velocity? Because I know for sure that it's not the velocity of the car from the first second to the last. The car started at 0 and then it got itself accelerating from 0 up to maybe 80, maybe less, maybe more. It had to make a turn, so he had to slow down. There was a traffic, had to slow down. There was a stoplight, so they had to stop. So for the whole journey, you cannot say that the velocity was 80 kilometers per hour at any part of the journey, but this 80 kilometers per hour is an average for the whole journey. So if I am asked to find the velocity at a specific time, like I want to find it at the 24th minute and 3 seconds. I want to know what is the velocity at that time. And that puts us in a problem, because to calculate velocity or speed, you have to do distance over time. So there has to be a time interval. But if you put the time interval as 1 minute, then that does not count as instantaneous, because I'm asking for at this instant. So if you say 1 minute, 1 minute is a long period of time. Like, what if you say, okay, time is only 1 second? Also, 1 second is a long period of time. So when I say I want to find the instantaneous speed, then time has to be 0 seconds. But if you put here distance over time and you put 0 in time, you will not find an answer because you cannot divide by 0. But you can use the limits when x approaches 0. When x comes really close to 0, what is going to be the velocity? Then you can find velocity. Of course, you're not going to find it as simple as this. There has to be a function, but this is just an overall explanation of a case where we can use limits to find something. And that's probably it. So how do we find limits? Well, this video has already gone for over 20 minutes, so I will make how do we find limits in a separate different video, and we'll just stop here, and I'm just going to upload the video right away, right after this one, so you can simply find it. It's going to be limits 2. This is going to be limits 1. What are limits and why do we use them? And limits 2 is going to be how do we find limits, and we're going to take different cases for different limits and how we're going to find them. I hope this lesson was enjoyable and educational, and don't forget to subscribe so you can easily find all the videos you need, and to write down in the comment section any requests you may have so it can be added in future videos. And thank you.